Hello and welcome to this video that goes through the Specimen Paper 1 for AQA Further Maths Level 2 qualification. This is the non-calculator paper. So, question number 1, solve the following equation: 7 times 3x minus 1 plus 2 times x plus 7 equals 3 times 6x minus 1. So the first thing we do is there's nothing easily that we can cancel here. So we're going to expand all the brackets out. So 7 times 3x is 21x. 7 times minus 1 is minus 7, 2 times x is 2x, 2 times 7 is 14, is equal to 6x times 3 is equal to 18x, and 3 times minus 1 is minus 3. The next step I would do is to put any like terms together, which are on either side. So here we've got 21x plus 2x, which is 23x, and we've got minus 7 plus 7, with 14, which is equal to 7. That's equal to 18x minus 3. And then the next step, I'd put the x terms on the left hand side and the numbers on the right hand side. So to do this step by step, we would minus 18x on both sides. So 23x minus 18 is equal to 5x plus 7 equals minus 3. And then we would subtract 7 on both sides, so minus 7 minus 7. That gives us 5x equals minus 3 minus 7 is equal to minus 10. And the last step is we're going to divide through by 5. We can keep the colours consistent. So divide by 5, divide by 5. So 5x divided by 5 is equal to x equals minus 10 over 5, which is equal to minus 2. So our answer is x is equal to minus 2. Question 1b, solve the square root of 3x plus 10 equals 4. So the first thing we need to do is get rid of the square root. So we're going to square both sides to get rid of it, because that's the opposite to the square root. So that gives us 3x plus 10 is equal to 4 squared. So 3x plus 10 is equal to 16. The next step we're going to do is we're going to subtract 10 from both sides. So therefore we get 3x is equal to 16 minus 10, which is equal to 6, and then we're going to divide both sides by 3. So that gives us x equals 2. So our answer here is just x equals 2. Question 2a, the nth terms of two sequences are 4n plus 13 and 6x minus 21. Which term has the same value in each sequence? So what it's looking for is it's basically looking for what, so 4n plus, so if you plug in the numbers, and the numbers would add up for each one, so 4n plus 13 would give you 4 plus 13, and which is 17, and then you put the 2n in, so 8 plus 13, 21, etc. Then the 6n minus 21, you would also have a sequence. You're trying to find the value that basically appears in both terms. For that, that means that they're both going to equal each other. So that's going to be 4n plus 13 is equal to 6n minus 21. So at some point they're going to equal the answer. So then from here, once we make them equal to each other, we can rearrange and find the n value. So we're going to, so the idea behind this question is that one of these sequences will have the same, so for example at an nth term, so maybe like the 7th term, both the 4n plus 13 and the 6n minus 21 will have the same term, will be at the same value essentially. So that's why we can equal them, and therefore once we've got that point, we can find the points of what term, essentially what nth term does that occur at. So once we get to here, the first thing we do is we rearrange the equation. So we're going to put n on the right hand side this time because it's got the bigger number. So we're going to subtract 4n from either side. So if we subtract 4n, we get 13 equals 6n minus 4n is 2n minus 21. Then we're going to plus 21 on both sides. So plus 21, 13 plus 21 is equal to 34. So 34 is equal to 2n. Then we divide both sides by 2. So 34 divided by 2 is equal to 17, and that's equal to n. So your answer here is equal to 17. So at the 17th term, both values are equal to each other, and you can always test your answer. And again, when you check through your answer, you should be testing your answer. So we would do 4, so 17 times 4. Again, it's non-calculator, so we work it out. So 4 times 7 is 28. 4 times 1 is 40. So that gives you 8. That gives you 68. So then it's going to be 68 plus 13. So 8 plus 3 is 11. So 1, 1. 6 plus 1 plus 1 is 81. So the 81 here at the 17th term, and then we can test this here as well. So it's going to be 17 times 6. So 6 times 7 is 42. And then 6 times 1 is 60. So it's going to be 2, 0. So 102. Then we do 102 minus 21. So 2 minus 1 is 1. Take 1 is 0, so 9 minus 2. 17 minus 2 is 5. No, oh, wait, hang on. I have done this. So it's going to be 102 minus 21. Oh, yeah, sorry, I've done this incorrectly. So this goes to, this goes to 0, this goes to 9, knock this off, this goes to, oh, sorry, this is a bit of a fail. So, start again, so it's 102 minus 21, this time we take the 1 off here, put it as a 10 here, so therefore it's 2 minus 1 is 1, and then 10 minus 2 is equal to 81. So you can see you get the same value there. Apologies for the slowness there. Yeah, so we can see that we've got our answer. So that's how you would check through at the end of your exam. You don't necessarily have to do it during the question because you want to move on probably and try and cover all the questions. And when you come back, just plug the numbers in. The first 5 terms of a quadratic sequence are 4, 10, 18, 28, and 40. Work out an expression for the nth term. So in this situation, you want to use the easy tactic for this one, which is using the formulas. So if you've not seen this before, we'll go through it with you. So we write out our sequence, so 4, 10, 18, 28, and 40. First of all, we find the difference between each of the terms. So 4 and 10 is 6, 10 and 8 is 2, 18 and 28 is 10, and 28 and 40 is 12. And then we find the differences between the first difference, so that's going to be 2, 2, and 2. And then the first thing we do is we then write out a set of formulas that we need, that we use. So the first one is, our goal here for a quadratic sequence is to get the term ax squared plus bx plus c. But there are 3 formulas that we can use that can find it using our original sequence. So the first one is a plus b plus c, and that is equal to the first term in the sequence, so 4. So we can say that a plus b plus c is equal to 4. The next one that we have is going to be 3a plus b is equal to 6, which is the second term in the sequence. So it's 3a plus b. It's not the second term, sorry, it's the first term of the first difference. So it's equal to 6. So it's the difference between the first and the second term. And then the final one that we have is we can find that we know that our a term is equal to the third difference, so 2 divided by 2, which is equal to 1. And so therefore from here we can say that, well, a is equal to 1. We can plug a into our second equation, so it's 3 times 1 plus b is equal to 6. So therefore we subtract 3 on both sides, because 3 times 1 is 3, so b is equal to 3. And finally we can plug it into our final equation, which is c. So it's going to be 1 plus 3 plus c is equal to 4. So it's 4 plus c is equal to 4, so c is equal to 0. So that means that our expression for the nth term is simply going to be 1x squared plus 3x plus 0. So simplifying that down, it's just going to be x squared plus 3x. And you can plug in your terms to check. So if you plug in the first term, so 1 squared plus 3 times 1 is 4, Second one 2 squared plus 3 times 2, so that's 4 plus 6, which is 10, etc. So you can just check your terms through. But that's a nice quick way of solving it. So to remind you of the formulas, if you're not seeing this again, the general form is ax squared plus bx plus c. A plus b plus c is equal to the first term in the sequence. 3a plus b is equal to the first term in the first difference row, so in this case 6. And then finally, suppose you could write it as 2a is equal to 2, or a is equal to the second difference divided by 2. The next question we've got is question 3. On the axis below, sketch the graph of y equals x squared minus 9. Clearly label clearly any point of intersection with the x-axis. Okay, so if we are sketching the following graph, we want to first of all label any points of intersection with the x-axis. So it's important that we get this first. So if it's with the x-axis, we know that y is equal to 0, because it's crossing this axis here. So we say 0 equals x squared minus 9. And from here we can actually just rearrange this equation. We can say 9 is equal to x squared. And then we can square root. Remember, when you square root, there's a plus or minus. So it's plus or minus root 9 is equal to 3. So plus or minus 3 is equal to x. So therefore, we know that at minus 3 and at 3, the graph will intersect, and that is the only point that it's interested in here. So we don't need to label any of the y-axis points or the turning point, so we can just draw a general U-shape that shows our graph, and this will pick up all the marks that we need, making sure that it clearly goes through minus 3 and 3. Again, the sketching part of it doesn't need to be perfect, but does need to be a general U-shape. The next one then is write down all the integer solutions to x squared minus 9 is less than 0. So for here, we are interested in anything where the y value, so remember that this is equivalent to y, so when y is less than 0. So that is going to be all of these values here underneath the x-axis. One thing to be careful of, that there is no equals to sign, so therefore we cannot include minus 3 or 3, because that's when it's equal to 0. But it'll be every other integer value here, so it's going to be minus 2, minus 1, 0, 1, and 2. Those all values will fit in. Again, you can test this by plugging those values into the equation. You should get a negative value. Next question, question 4. A function is defined as so it's a piecewise function, defined as f of x equals 3x for 0 between 0 and 1, 3 between 1 and 3, and 12 minus 3x. The question wants you to calculate the area enclosed by the graph y equals fx and the x-axis. So first thing we need to do is we need to draw out our graph so that we can then calculate the area for it. So the first thing we've got is 3x between 0 and 1. So we know that when x, so for here, the way you could do this is you can draw little tables. Remember that f of x is equivalent to y equals, so we've got y equals 3x, and this is going to be a straight line because it's a y equals mx plus c curve, but obviously with no c value, so that we know that when x is 0, y will equal 0. When x is 1, y will equal 3. So therefore, for our first one, we can do 0, 0, then when x is 1, y is 3. So that would be our first line that we can draw. Then it says between 1 and 3 that f of x is equal to 3. So for this one, that is the same as saying y is equal to 3. So between 1 and 3, we can just put that in, and there's our answer. And then the next one says that between 12 minus 3x, between x is 3 and x is 4. So again, we can do a similar idea here, 12 minus 3x. We can do our x values and our y values for our domain that we're interested in. So here we've got x is 3, so it's going to be 12 minus 9. 3 times 3 is 9. So 12 minus 9 is equal to 3. So when x is 3, y is 3, so that shows that it starts from the point where our previous graph ended. And then we can test the last one, so 12. So when x is 4, it's 12 minus 3 times 4, which is 12, which is equal to 0. So therefore it goes back to our point. And that is how we can draw our graph. Go back to y is 0. Now if you want to find the area under the graph, you've got two choices here. You can either split this into triangles. and calculate the area of the triangles and the area of the square. Or this is also just a trapezium as well, with sides of 2 on the top and 4 on the bottom, and it's got a height equal to 3. Again, to check the formula sheet, see if your trapezium area is there. We can see that it is not there. So this is something that you'll have to remember in the exam, that the area of the trapezium. Again, if you can't remember the area of the trapezium, then you can find the area of the triangles and the area of the rectangle, but it's a much quicker method of just doing. So the area of a trapezium is A plus B over 2 times height, where in this situation A and B are perpendicular sides and H is the height. So plugging that in is going to be 2 plus 4 divided by 2 times 3. 2 plus 4 is 6 divided by 2 times 3. 6 divided by 2 is 3 times 3 is equal to 9. So your answer is 9 units squared. Next one we have is question 5. The graph shows how two lines A and B. The graph shows two lines A and B. The equation of line B is 2x plus 2. Work out the equation of line A. So this one is quite a tricky question actually, but we can work out partly using the scale, because we can dissect from B a key value in the y and the x. The first key thing here is that we want to find the scale of our graph. So let's start with the y-axis. We know that so essentially what this point here is. So what does that indicate? So that is when x is equal to 0. So that means that y is equal to 2 times 0 plus 2. So y is equal to 2. So we know that each of these big scalings is equal to 2. And then from there we can deduce the a. So we know that this one is 2, this is 4, and this is 1, 2, 3, 4, 5. So there's 5 scalings, there's 5 small units, I suppose, between each big unit. So each of the thicker one, so it's 2, and then this one must be 4. 9 is 2, and this is minus 4. So therefore this is halfway at 2.5. So we know that it crosses at minus 3. So we know that A is a straight line in the form of y equals mx plus c. So we know that c must equal to minus 3. The next step then is to calculate the gradient. To do that, the gradient, remember, is equal to change in y over change in x. So we also need to find what our scale is on the x-axis. So we know that the gradient of the B line, m, is equal to 2. So we know that here, so we can make like a little triangle here. We know that this is 2, but we want to find out, well, what's our scaling here? So we know that 2 here is equal to change in y, which is 2, divided by the change in the x. And that change in x is represented by the difference here. So this dotted line here, we can then rearrange, so it's going to be delta x, so times both sides by delta x, and divided by 2. Delta x equals 2 divided by 2, which is equal to 1. So we know that each one of these, each big one here, is equal to 1. So that means then that we can find our situation. So we know that if we pick any point there, well, let's pick this point here. So we know that at that point we can draw our gradient here, so a little gradient triangle between each point. So we know that this one and this one is equivalent to 1, because each of the big squares is equal to 1. So we know that our delta x is equal to 1. And we know that from between here and here, this is at 2.5 little squares. So we also know that this has moved up by 1. So our now gradient, change in y over change in x, is equal to 1 over 1, which is equal to 1, which is equal to m, which is our gradient. So our final answer for this one is y is equal to 1x minus 3. So y is equal to x minus 3 using this graph. And that brings to the end of questions 1 to 5. In the next video we will go through questions 6 to 10.